Awesome. Thank you, Ron. Thank you for having me. So, everyone, I'm Cheryl Joseph, and I am a solutions architect at AWS. I've been here at AWS for a little over 2.5 years now. And the topic of this particular segment is modernizing core banking systems using AWS. Uh, for a little bit of background about me, prior to joining AWS, I worked my entire career at Caesars Entertainment. It's one of the largest casino gaming companies in the world. And I held several roles there, primarily to do with application development. And over here at AWS, I support, help customers in the Pennsylvania area. And application modernization is quite near and dear to my heart. So, as you know, a few of my customers are embarking on this journey. So, I'm really, really excited to be over here. And Ron, thank you so much for inviting me. And give me a minute. I just wanted to turn off my video because I'm having some bandwidth issues today. Okay, perfect. Um, talking about banking and AWS. Overall, banks and many other companies are facing, facing pressures. They're facing pressure to modernize, and they are facing pressures from customers who, for example, are expecting a more personalized experience, and they really want to be treated more holistically. And additionally, there are fintechs, they're operating with a lower cost to serve customers, and they're really rethinking the whole economic model. And then obviously you have these evolving compliance needs and regulatory needs. And you have the regulators who are really forcing banks to give their customers more control over their data, and to even improve their reporting and their loan portfolio transparency. And so banks are taking different paths to modernization. I wanted to discuss a few use cases here. And so if you're going from the left to the right over here, you see banks are augmenting their core. And by saying augmenting their core, what I'm referring to is that banks are building modern cloud interfaces on top. So customers or banks, or this doesn't necessarily have to be a bank, this could be any company who goes down this route. You're really keeping your existing core systems but looking to provide a better experience for your users or your customers by building a modern digital front end really on top of these legacy systems. So you still have those legacy systems, but you're just augmenting that. And the second use case I would say is migrating your core. So, and how banks are really, we at AWS see banks doing this is by moving them to the cloud and then gradually refactoring. So, this really would be customers who might be wanting to quickly get out of their data centers and then want to migrate all of their platforms and then refactor. So really lift and shift initially and then modernize later. And the third use case that we see is banks who really want to replace their core. So these could be customers again who have taken the time to make a more strategic approach and to migrate their core banking systems from the beginning with a new cloud native design application. And so really what this really means is launching a cloud native bank independent of the legacy infrastructure. And the last use case option I would say is really launching a new bank. So this really isn't, I wouldn't really say it's a core migration as such, but with this option, the customer, the bank, whoever that might be, you're leaving your existing core as is and you'll build out a new system and then move your users gradually. Um, so now let's talk about some considerations on your path to modernization. So firstly, things that need to be considered, and I keep repeating this, and I'm going to say this again, like I'm talking over here about banks or financial services, that again, these really apply across the board, is they might be slightly different from industry to industry. But regardless, firstly, you need to understand how diverse your product offerings are. Um, what is your underwriting process? What's your maintenance and your service model? And how do your modernization goals really align with your regulatory posture? And, this is really important when it comes to financial services. And do you really have the support staff to maintain your modernization goals? Because you really do need them. Without them, you'll have a modern system, but nobody to support it. And how quickly would you like to drive change for your business? So these again are the business considerations. However, if you're developing a technological solution, you need to take into account the technical considerations when modernizing your core banking systems. So one thing would be, is this going to be a SaaS or a self-hosted solution? So is this a software as a service, or is it self-hosted by the bank? And, some core banking providers only provide a SaaS deployment option, and which would mean that they would manage the platform for the customer, and the customer connects to that particular platform using a secure mechanism, like, for example, a private link, while others provide the flexibility of being able to deploy within the bank's AWS environment. Or it could be, like we see in the middle over here, a cloud native deployment. And really, cloud native platforms are usually built as microservices. And we'll be referring a lot more to microservices as I go along in this presentation. And really, microservices are able to scale individually with the growth in business. And some cloud native solutions are also built with event-driven architectures. And we are seeing a lot of companies, a lot of organizations going this event-driven route, because this allows you to decouple your microservices, and allows those microservices to scale independently. And and you can, so basically you can add more microservices as you need. You can remove it without it impacting the others, so removing the tight coupling. And also, another thing that you would need to consider is, how flexible is this? For tech-savvy banks, tech-savvy customers, you may choose to build your own core banking platform, right? So you have complete control, while others may choose partner solutions over which they may or may not have complete control. And some partner solutions offer more control over the core systems and allow you to build completely, while for others, it just might be a configuration change. So now that we spoke about these two different types of considerations, let's dive a bit deeper into those use cases that I mentioned previously, about use cases that banks take into consideration when modernizing their core banking platform. So starting off with augmenting your core. So let's start with, what is that? I briefly mentioned that earlier. So augmenting your core would be like a great option for banks who are really not able, or maybe not even willing to modernize your core banking systems. Because if this is the bread and butter of your company, you might have some reservations, because the last thing you want to do is have any impact to your customers. And so by adding an overlay on top of the core with modern API interfaces, the bank can really build more modern user experiences for the customer, for the employees, and really enable third parties to build on top of this infrastructure. So there's obviously there's benefits. One of the benefits would be you can integrate with your core banking systems, and you can power modern API interfaces, and these can be completed in a much shorter duration, particularly if you have the support of experienced AWS partners, right? We had OutSystems speaking previously. And so if you have the support of experienced AWS partners, this can help speed up this process. And you can also, while you do this, and as you do this, you can also build additional customer experiences that can be done, in parallel, and as long as your APIs are defined upfront. But there are some disadvantages with this approach, and these could be the back or the middle office effort. This could be brittle. And so while your modern APIs are essential for really smoother customer experience, it's quite often difficult or sometimes even impossible to automate the back office processes associated with this given API. And so as a result, we see it's fairly common for some APIs to actually initiate manual back office tasks that either fall into existing manual workflows or even creating new adjacent workflows. And also, when you give your customers an easier way to initiate a given activity, this can also lead to increased volume in these manual activities that I just mentioned. So say, for example, you're making it easy to dispute a transaction in-app. And this can often lead to more disputes which again might have to be managed manually. So here is a reference architecture for augmenting your core. So as you see over here, all of your legacy infrastructure is on premises at the very bottom right. And this can be abstracted away by writing your APIs on top of your legacy platform over here. So you can create an API abstraction layer. You can create private APIs on Amazon API Gateway, which will now integrate with your legacy platform. And once you have the abstraction layer created, you can now look into building additional functionalities, such as, for example, you could build a digital onboarding platform shown here on the right. And it has, as you can see, it has a front end that is using EKS, which is the Elastic Kubernetes service on AWS, and to run your microservices. And it's also using a modern database, which is Amazon Aurora. Your backend over here doesn't have to be using EKS. It's using Amazon Lambda as for its compute layer, which can be triggered from DynamoDB using DynamoDB streams. And these in turn are communicating to other AWS services. So you have Textract over here if you have a use case where you might want to automatically extract text or handwritten data from scanned documents. You might want to do image recognition, and you can use Amazon Recognition. You might want to actually store this in an object storage, and Amazon S3 will enable you to do just that. And these are all modern services that you're using, but you're still keeping your legacy core banking system intact over here. Over here, similarly to the digital onboarding system, you could also write an open banking system. And again, this is using a modern application stack. Your API backends are using EKS and Aurora. You could be using an IDP, an identity provider of your choice. And these could again be fronted using Amazon API Gateway. And then you could connect to your private API endpoints using Private Link. So this would be an initial architecture of like if you wanted to augment your core. So now that we've spoken about augmenting your core, let's talk about the next use case, which is, hey, taking a step further, let's talk about migrating your core. And transforming the core is often, many a times, one of the first steps taken by banks that are interested in modernization. Because augmenting your core is great, but sometimes banks really want to move their physical, reduce, I would say, their physical data center footprint. And so I'm sure you've all heard the term lift and shift. And lift and shift is really lifting what you had on in your data centers and moving that to AWS. And that is really what we see portrayed over here. Your legacy core banking systems have literally been lifted and shifted over here, and these, I would say, are macro services, right? So you have the general ledger macro service, loans, accounts, deposits, and other macro services. And with this approach, the key benefits are you see a rapid return on investment, and you can also auto scale on EC2. For example, if these are running on EC2, you can auto scale on EC2 if you are running if you have any spikes. And with this rapid return on investment, you are turning your capital expenditure with a high upfront and maintenance costs into your operating expense. So you're trading again CapEx for OpEx. And you can also meet your business needs because you can scale if you're using our auto scaling. And this comes as an alternative to forecasting and preparing for peak demands well in advance. However, the disadvantage with this approach is that it still requires it's not really architected for the cloud, right? And so it still requires an overlay to build modern front-end experiences. So, while lift and shift can be financially productive, the hard work of refactoring workloads for cloud optimization and really creating modern interfaces that you see on the right over here, they're still really required to truly modernize your applications. So let's look at reference architecture over here. So if you were migrating your application, doing a lift and shift, and if your legacy core banking platform was a standard 3-tier architecture, then your architecture would be similar to what we see over here on the screen. Here you would have your 3 layers, your front-end layer, which is over here in the public subnet. So your web applications would be running in a public subnet. Your middle, your application tier would be over here running in the private subnets. And then, of course, you have your database. So there are some immediate advantages that you can gain by doing such a migration. Right? You can use auto-scaling groups to scale your front end, auto-scaling groups to scale your application layer. You can use Amazon RDS, and which offers multi-availability zone functionality right out of the box. You can also use other services listed on the right over here. So you can use Amazon AWS KMS to encrypt your data at rest. KMS is a key management service. Or you could use Secrets Manager if you would like to store your secrets without really having to worry about, building and managing such platforms on premises. But once you've migrated your core platform to the cloud, then you could embark on actually the modernization journey that we've been talking about, where you could split the monolith or the macro service that I spoke about earlier into actually microservices. So in this architecture that you're seeing over here, you have different microservices for loans. You have a microservice for deposits and a microservice for mortgages, which are, again, fronted by an application load balancer and a web application firewall. So, and you're using different types of databases. You're using the database that is the right choice for the task at hand. So, we have seen multiple customers lean towards using Amazon QLDB, which is the quantum ledger database, for their rewards database. We've seen customers using Amazon Aurora as their ledger database, or maybe even DynamoDB as well in some cases if, they are comfortable using NoSQL databases. And then they're architecting their platforms around it. So, and also we are seeing customers, enable and expose their APIs and additionally use event-driven architectures for internal communication between services. So as you see at the very bottom over here, their messages could be published to Amazon MSK, which is the managed service for Kafka, and they can be subscribed to by other microservices that are really interested in in this particular message. So as you can see, this is again taking that architecture that we had previously and going a step further, right? Um, so now that we've referred to this, I want to quickly talk about mainframe modernization on AWS. So why I want to really quickly cover this topic is many banks have mainframes. And, I didn't want to, go on to the next topic before quickly talking about some of the challenges that banks have and how you can overcome this with the services on AWS. So, um, you know, the challenge and mainframes, sometimes can hold financial institutions back. So basically, it's really difficult to deploy new functions with mainframes, and you can obviously, but it takes more longer time. And many of these are using archaic interfaces and protocols. And for if you want to adopt a CI/CD pipeline or microservices, it's not, agility can be this can actually affect your agility if you're using a mainframe. Cost is another factor with mainframes. They can end up costing up to millions of dollars for running a mainframe. And also, if you'd like to perform innovation, like I said previously, it takes time to do this. And then you also have the skills shortage, right? Because a lot of the mainframe specialists have either retired or will be retiring soon. So by modernizing your mainframe, which many banks have, you can take advantage of obviously agility, which I spoke about previously, the challenge, and you can, because now you can use modern CI/CD pipelines. You can take advantage of the security that AWS provides, and obviously build your applications to be secure, following all the best practices that AWS mentions. And again, security is you know is the topmost priority for AWS, and for banks, I would see this being no different. So AWS is obviously designed to run to meet the requirements or satisfy the requirements, I would say, for the world's most sensitive organizations. So you can take advantage of that. You can take advantage of high availability by running across multiple availability zones, and also designing your applications if you need to replicate across multiple AWS regions and have a DR solution in place. You could manage cost because now you're doing a pay-as-you-go process. You're not paying for everything up front, and so you're eliminating your capital expenditure. You're shrinking ISV licenses and the like. And then additionally, you've got all this data that is present in, if you were running on a mainframe, could be decades of data. I think about what you can really do with that data. You can, perform analytics workloads. You can do machine learning, and really, you can really, do different things with this data that previously was really hidden and nobody had access to. And then, you can easily attract new talent. So I wanted to just quickly talk about AWS Mainframe Modernization. And this is a service that was announced in reInvent of 2021. And what this really does is it helps you to safely transform and expand your legacy locked business value using a modern tooling. And it really brings the agility to mainframe workloads, both at the application level and even at the infrastructure level. And I know that I think Ron had a session previously on that talks about AWS mainframe modernization. I'd really suggest taking a look at it because that was a great session that really had a lot of good information. And in AWS Mainframe Modernization provides the capabilities required for analyzing, for transformation, for development, and for the ongoing operation of your mainframe workloads. So it isn't just like, hey, bringing it on AWS and that's the end of it, and there it goes, and you move on from there. It really helps you to operate your mainframe workloads. And it also uses, as you can see, it uses integration partners like Blue Age, which is actually now part of AWS, which will help you to refactor your applications. So if you have, existing applications written in COBOL or RPG or others, you can use Blue Age to now transform this into modern distributed applications relying on Angular and Java and Postgres and other databases. And same thing with micro focus. This is really, it will help you to re-platform your mainframe applications, and it allows you to preserve your application assets with like minimal changes while modernizing the infrastructure. So, the AWS also has the Mainframe Migration Acceleration Program, and it's really a program that takes a holistic approach to migrations, and it helps you to navigate the challenges, avoid mistakes, and really accelerate your migration. So you can read up on it. There's a lot of information out there on the web, and this is really a program where that introduces AWS investments on multiple levels for workshop, partners, ProServe consulting platform, and others.
Hey, Cheryl.
Yeah.
We've got about 1 or 2 minutes left, so I just want to keep you aware of the time frame.
Yes, sure. I'll be quick. Thank you, Ron. So let's really talk about the third option, which is replacing your core. And some of the key benefits for replacing your core is, like I mentioned earlier, you're removing that middle macro service layer and you're going directly into a more modern solution. And so this will encourage a more nimble technology team. It will, rapidly improve innovation cycles, and this can improve customer experience. But again, the disadvantage with this is really time, cost, and complexity. So let's look at an architecture for if you were building a core banking system like a modern application. So as you can see, here's a reference architecture that showcases how you can go about building a cloud native core banking system for unsecured lending. So this architecture uses Amazon Aurora that you see over here. It uses Amazon Aurora as your ledger database. And, again, it's a modern architecture using API gateway. And Amazon EKS and Aurora are used to build your microservices. And you also have connectivity to your existing payment systems. And these can publish to MQ, Amazon MQ. And you have your other applications that are deployed on EKS using DynamoDB. And if you want to perform reporting and analytics, there's a slew of analytics services that are listed over here, and you can use QuickSight for your reports, right? So you can see over here how all of these services allow you to build a more robust application, and which will really scale based on your needs. And this again over here is similar to the previous slide. We showcase how you can build a cloud native core banking system, again for unsecured lending, but instead of using Aurora, we're using Amazon QLDB. Okay, so that's the Amazon Quantum Ledger database, and it's a purpose-built database that provides a transparent, immutable, and cryptographically verifiable transaction log, in addition to it being a database. So again, just a quick recap, your banks can augment their core by keeping their existing core systems and building modern interfaces on top. You can actually migrate your core, so you really do a lift and shift initially and then refactor gradually, or really totally replace your core by building a new cloud native design. So with that, I wanted to say thank you very much. Thank you for joining. I hope you learned something in this session. And here is my contact information. Feel free to reach out to Ron or to me if you have any questions. And Ron, thank you so much.